Welcome back to another Tech Day Live. I will do the following things today. Hopefully, I will make it. I want to finish some of the Linux/Unix videos that I have been planning to do, and also we might do some langchain, we might do some machine learning. It depends on the time we have available. And the first thing I wanted to do is to run my service, tablet stream service. So I think this is the one. I never know my scripts by heart, but I have one problem. Usually when I connect my cable, the charger cable, to my laptop from my tablet, I get a notification on my tablet saying, "Oh, do you allow file transfers and do you allow the interaction between your tablet and your computer?" And now I have a different kind cable and it doesn't let me do this. So let me just see what happens if I click start. This is actually the expected behavior. I got my window moved to my primary window. My window moved to my primary display, but I don't have any screen sharing. So most probably I will need to plug this out, get my other cable for this. Yeah, let's do this. If you hear some rustling or unexpected sounds in the background, it's just my cat that is roaming around my workspace. Okay, now I have allow access to tablet data on my tablet. So if I do clear and if I run this again, it should work. Now I should get a projection on my tablet here. Still nothing. Still nothing. Shit. I actually had another notification on my tablet now that I had to accept. So hopefully now I will get a projection. No. I have another one. Wait, let me do this again. Restart tablet stream service. So it seems like my script isn't configured the best, because if I don't accept the tablet sharing immediately on my tablet, I never get. Here it is. Yeah. So I actually had to accept tablet sharing twice. All right. Something to think about. Okay, let me switch back to my tablet. Let me increase the working environment size. What is now important, and it's related to system logging, are users. I'm going to use a different color. So basically the concept of users in operating systems is relatively simple, right? You have different separate entities that want to enter a computer for personal use, and they are separated either by passwords or they are not separated by passwords. And once they log in, they each have, a different environment, a different wallpaper, things like that. In Linux, at kernel level, users are just numbers. So users are just in Linux. Users are just user IDs. But this is only at the kernel level. At the user space level, we have usernames or usernames at the user space level. So what applications that use Linux are doing is that they are translating names from numbers when they interact with the kernel. And there are methods for that, like get uid, so programs. So they translate user IDs into names. Now, each user in the system has a line in a very specific file here. Okay, let me do something. Because I want to show, oh, this is a big board. I'm gonna take a small one. I want to show an example of a etc/password file, but I don't want to show mine. So I'm gonna do something which hopefully will work. adb push Let's just see where this file is located. It's in downloads, adb push downloads carbon.png. Carbon is actually pretty great. It's a way to prettify your code, and I use it all the time. Let me just show you. It's really great, and you can export images and everything. So adb push carbon phd SD card download. Okay, it worked. So hopefully this will work. How many? So wait, what I need to do? I want to push carbon into my SD card download, and now cool. I just pushed an image to my tablet, and maybe now it will be a bit easier to. Yeah, I took 10 minutes in order to set this up, but hopefully now it will be a bit simpler. This is an exemplary file. I can also stretch it. I'm gonna stretch it just a little bit. Can I write over it? I can. Good, good. I really love Samsung Notes. It's a really great note-taking app. I would like maybe to find something better, something suits me more, that's more dynamic, but this is probably the best note-taking app that I've been working with in a really long time. Okay, so each user, and again, this is an exemplary etc/password file. Can I write over it? Yeah. Can I lock it? Just a second, let me just see. Remove anchor to text, fit to page with edit image, clipboard, share, save image, lasso, crop, select all. Yeah, these are the things, for example, that I would want to have in my image editing, in my note-taking app. Maybe there's an option to do this. I'm not good enough to understand, but okay. So each user on the system has a line in etc/password. The first one is the login name. The second one is the encrypted password flag. X is pointing to a shadow file. UID are user IDs, unique numeric IDs. The next ones are group IDs. What else do we have? This is here. Audit daemon, backup user, SSHD daemon, my SQL server. These are real names and infos. What else do we have? var/lib/audit, our paths to user's home, and this is the shell or the program that's launched after the login. Now the password fields. As you can see here, none of them, I believe, none of them are directly stored in etc/password, because this file is human readable. If I say cat etc password, I would see all of this content right here. So what happens is that there is another file that stores passwords, and that file is in etc/shadow. And again, X means that we store a password in the shadow file, and anything else, let me just see if we have anything else, like a star or sometimes an exclamation mark, means that an account is disabled, that there's no login. And we have some that are created without any password requirements. I don't see them, but if we see a blank field here, for example, two full stops. No, how is this sign called? A colon. A colon. All right. If we have two colons, then no password is required, which is extremely unsafe. Let's talk about UIDs and group IDs. So UIDs are a way on how the kernel identifies the user. The UID of 0 is the root. UIDs that range from 1 to 999 are system accounts. UIDs that are greater than 1000 are regular users. And the group ID or GID determines which primary group the user belongs to. The real name is just that metadata name, other information. Some older system used it for contact information. Now, these guys right here, the home and shell info are telling us where personal files and shell configs live. And shell defines what interpreter runs at login. So the most common ones are bin bash, no login, meaning this account is not available. Bin false also, yeah, no login, no login, no login, no login, no login, no login. Yeah, most of them are no login. Now let's get back to the users. We have special users and we have also pseudo users. As we already know, root is a special, root has unrestricted access. Then we have daemon, we have bin, we have sys. We also have here, I think, nobody, a user that is highly unprivileged. It's used only for sandbox processes. And pseudo users are no real people, but system service use them for isolation. They can't log in, but you can run daemons as them. But kernel only treats the user with the UID 0 as special, or all others are just conventions. And also there is the etc shadow file. I'm not sure this one, but it's similar in structure to our etc password file. That basically it has the username, and then it has the encrypted password. Afterwards, we are showing the last password change. All divided by colons. Minimum days before an exchange. Days for next change. Password expiration. Warn days before expiry, inactive days after expiry, stuff like that. What else? Groups. I haven't seen a lot of group use, and I'm using Linux for maybe a good chunk of a decade, probably. But groups are used to control shared file access. You can create a group using, for example, sudo group add editors, and I can say, oh, what if I add users to this group? User mod editors user 1, same thing here. I'm just gonna add user 2, and then I can assign a file specifically to these users in a group, specifically to this group, only for the members of editors to read and write in a certain folder. Where am I? I'm here. I push the image last. What's my ID? Okay, so my ID is 1000. I'm actually a human user account here. And what groups do I belong to? Groups. So these are the groups I belong to, which is actually the name of my username, atm, cd-rom, sudo. All right, I'm also part of sudo, plugdev, users, ipad. I don't want to do this, but I could also add and remove users. I could do sudo add user test user, or if I want, this is how I add the user. Adding user test user. Okay, I also need to set a password. It's too simple. I hate this. Passwords do not match. I hate this. All right, I don't even want to create a new user. Oops, clear. But I could create a new user. I could also lock and unlock accounts and things like that. And if you are interested in a bit more knowledge, let's see. Because I searched specifically, what's the difference between the shadow file and the password file? They contain the same data. Why are they two files? Are they different? So the password file had all of the user data, and there was no shadow. However, it was discovered that a dictionary attack could be done on the file to discover passwords if they are in a dictionary. Therefore, it was decided to remove the passwords from password file, as it was used by many programs. The passwords were moved to shadow, and this file was made so that only root can read it. And when we open etc password has an export the password field, the shadow file only shares the first field. And shadow has been expanded to contain other password management fields. What is another interesting question? Wait. Oh, okay, this one is really interesting because I heard about nobody. Why might the system service use a user like nobody or the data user? I thought nobody user. Is my system safe? I am new to Linux, so sorry if it's a noob question. Recently I installed Manjaro for gaming and learning programming. I never checked the users in my system through system settings, but now I have to create a new user for managed school. So I visited the user section. I found a starter username nobody. I don't remember creating it, or was it created during setup or something. Man, this poor dude. I can just imagine how scared he was when he saw that. The nobody user is a standard account used to offload processes to a user without many permissions. A lot of small things get run under the nobody users. It's really nothing to worry about. Now, if a hacker had gotten into your system, they could also run processes as nobody. If I was this guy, and I read the first sentence, I would be, oh, so I'm not compromised. I actually save. And I read the second sentence, which, I don't know, it sounds like, oh, you go for a doctor's checkup and the doctor says, oh, you are actually pretty healthy, but people with the same symptoms you have often get, I don't know, cancer or something. Of course you would be scared. I don't know why someone would double. I don't know why someone would mention this. You're safe, mate. Just Google things to check your sanity down the line. Nobody's safe. Ah, nice one. Okay, this is actually pretty interesting. There's another question asked. How can you safely edit the password file without risking corruption? I don't want to read AI-generated answers, even though I use AI a lot. I wanted to see what users are saying. Oh, editing password file for privilege escalation. Is it safe to edit etc password? All right. I need to change the real name of a user, not the username. For example, if I have and I want it to be, so it's basically just the metadata that Richard Boonen wants to edit. And he wants to, all right, change the surname here. Can I just edit it manually, or will that negatively affect anything? For example, SSMTP. The username can be changed safely using user mode, but I never had to change the real name before. You can change the username with the user mode C command. Okay. So basically, it's doable, not recommended. Good to know. Good to know. Another good question. Can two users share the same UID. What are the side effects of having several Unix users? Okay, why can I create it? This may be more grounding. There are actually valid reasons for this. For example, I used to work in a lab where we each had our own computer, but our home was in a shared drive exported by a server. So my home was users/Terdon. Since the users folder was actually not on my local machine but exported over NFS, for any analysis that was heavy on input-output, I would use data stored on my local hard drives so as not to burden the lab's network. To that end, and everybody else's had two users. One was that system-wide and one that was local to the machine in question. The local user home was right. Linux does not protect you from yourself. If you really want to sue root and go into the files and give all the users the same UID, you can. It's just a text file. But you really shouldn't if you have unintended consequences. What are the unintended consequences? I love the way how this is like formulated. The question said, what are the side effects of having several Unix users share one user ID? And the answer flipped the question on its head and rephrased it, saying you can't have several users with the same UID. If they have the same UID, then they are the same users. What you have is multiple entries in the user database for the same user. That's possible in all Unix variants I've seen. The name determines which entry is used and thus which password, home directory, and shell applies at login time. The first entry determines what... So, let me think about it. We are all referencing the same users. We are just giving them different aliases, different names. And depending on the entry you are using, it's just a different control for one single user. It's also error prone. You need to use if all you wanted was to have the same username for SSH, then the way everybody else does it is with aliases. Error prone because you feel so. Okay, interesting. Also saw a discussion started here. A discussion that, wow, so this answer was written in 2014. DLS, so stop being evil, answered into, alright, so I thought these two users were the same ones. having the same discussion for 10 years. That would be something. That would be something, right? So look at this. We learned that the shadows file is holding the passwords. So what would happen if we would delete shadows file? So let's see. I was going through my network security notes and fiddling through my system. Man, the poor dude is was most probably scared shitless, and now you also downloaded him. I accidentally. How can you accidentally delete this file, man? Wait, let me. Currently, I'm on my system as I can't log out. If I do, I will lose it forever. So now I have... What? Can anyone tell me how to generate and get my shadow file back? I don't want to delete this OS. I have looked for its answer on Stack Overflow or other Ubuntu for nothing has come to close to solving the issues. Alright, so this person actually answered to themselves, which is really cool. But I want a real question. How to recover the deleted files using... But this is not what I wanted to do. I wanted to know what happens if... Okay, I have deleted etc shadows. What now? Here's a guide. You may delete a file called shadow. If you try to boot into a single user mode. Alright, so the file was no more. The shadow file was no more. And all account logging got disabled. So FTP was working because prot FTP was built using a MySQL database. Okay, reboot server. Select recovery mode. Go to the end of the line and type in it bash bin bash. Alright, so you need to gain root privileges and a root shell. And then you need to mount your partition manually. And then you need to rebuild the shadow file from the password file. And then block all non-root login until you fix all the password related problems. And then update all user passwords in a batch mode. Oh man, this is quite a lot of... And this was initially written in 2005. Amazing. I love it. I love it. All right, let me close this. Yeah, both of those. Let me take a quick break. And then I will continue with langchain. So, be right back. Okay, let's do some langchain work now. Let me just open my terminal and let me test my script again. I love testing the scripts I write all the time. If I press enter, as I said, this script should move all of my other windows to primary screen, which is my laptop. And it should only open my screen copy on my screening window, which is the one that I'm using to record. Tablet stream service, user start, enter. For some reason I implemented, okay, this is good, 1, 2, 3. After 3 seconds, it moved to my primary, and after 3 seconds, it's also open my screen copy. Amazing. I don't know why I put these timeouts. Do they even do anything? Who knows? Okay, let's continue. So the next step should be to write and implement an agent. If I'm not mistaken, and I will just make sure I'm not wrong on this one. Oh, because we want to implement an agent, we need also to understand that agent implementation langchain has been under significant shifts over time. We need to understand, what agents looked like originally in langchain, how they evolve, what broke, what got deprecated. How the newer architecture looks like, pros and cons of old versus new. So langchain being a pretty, let's say, new library, and it was built originally in 2022-23, the agent approach was simpler and more rigid, and there were some key patterns. We would have the agent executor, let me just write first approach. We would have something as that served as an agent executor, and it would most probably be I think I wrote this the wrong way. Initialize underscore agent, which is a central entry point. We provide a list of tools, the LLM we are using, and optional parameters. And how this works is that the initialize agent function, this function would return an agent executor that orchestrates reasoning, tool selection, execution, and looping. This is now completely deprecated, I believe, in the newer versions of langchain. And agents were differentiated by agent types. And this agent type enum would dictate how reasoning and action selection works. Like we will have zero-shot react, the agent reasons and acts in a single step without prior examples. Conventional React, designed for chat settings, integrates memory and conversation context, and the agent would use prompt templates with instruction that mix reasoning plus calls to tools. And optionally, agents could be given a memory component. But in early versions, memory integrations were somewhat optional or ad hoc. And the basic loop would be, so the agent asks the LLM what tool to call next. And then this tool would be executed. We would feed the results back, execute, get results. And rinse and repeat. Again, this is actually the same thing that distinguishes a chain, which is a fixed single pass, from an agent, which is adaptive, which is looping, and it learns on its own, let's say. Now, how it evolved. So we had some limitations with the original approach. Because we had initialize agent, it was one size fits all executor. It was relatively inflexible for more complex workflows. We had to do memory state handling more critically, becoming more critical, but it was not handled well. And then we had to scale and to learn how to scale. So over the time, the langchain team restructured and introduced new abstractions. First thing, how it evolved, initialize agent got deprecated. Okay, so I just met with the guy. He's already out of the game. And then specialized methods were added. So we had specialized instructions. Such as create React agent, create JSON agent. Specialized instructions were added. So instead of a catch-all, the initialize agent users now are calling more specific functions that are tailored to the pattern they want. Also, there is something called line graph, which is more about agent orchestration, stateful execution, and workflow graphs. I don't think this new implementation was backwards compatible. So a library was added to make it backwards compatible while developers can migrate the agents gradually. And then we have langchain 1.0. So we have create. Now we have create agent abstractions. This is a high-level interface. It's consistent across agent types. Then we have graph-based orchestration. That's why the library is called langgraph, because agents are treated more like components in a graph. And we have nodes. Nodes represent tool usage, decision steps, branching, etc, etc. So these are the steps. Now let's do some implementation. So let me just give you some more info on this. A regular LLM like GPT-3, GPT-4, 5, Claude, Gemini. So it's a statistical next token predictor. It takes in text, predicts text. So I don't know. I don't think I'm gonna write this. I don't think it's important. Maybe. So that's it. That's all it does. It has no internet connection. It has a pretty substantial amount of data, but it has no internet connection. It can't do anything live. It has no real-time knowledge, no APIs or tool accesses, and no state or memory between runs. So, no internet, no APIs, no state, no memory, etc. So if I would ask, what's the weather in Paris right now? It can guess based on its training data, which might be months or years old, but it can't actually query a weather API. It might say, it's usually 15 degrees in fall, but it's not real fact retrieval. It's not real data. It's just text prediction. So in order to add real functionality and to make LLMs useful in the real world, we combine them with tools or external functions. And that's why I think I mentioned here somewhere tools. So what tool to call next? So tools could be web search, calculator, weather APIs, database queries, internal company APIs, stuff like that. And it basically how it works under the hood. If I ask what the weather in Paris right now, LLM will say, in order to answer this, I should check the current weather in Paris. And I'm gonna call an action which is called the weather API, and I'm gonna input Paris, for example. Wait. So weather in Paris. So the LLM reasons like this. In order for me to answer this, I should check what the weather in Paris is. And as a thought, we have the action. The action is called weather API. And the input is Paris. And now the action right here is being interpreted, and it's gonna be executing the actual weather API. And the API results come back, and then so we have the results, and then LLM continuous reasoning. LLM itself doesn't fetch the weather. LLM decides to call a weather fetching tool, and the framework handles it. For example, let's do this. Oops. So, ready when you are. If I do a plus here, if I do web search, I can say, what is the weather in Paris right now? Oh, so it seems like the weather in Paris is the same like on the surface of the sun. But these are not, I assume these are not Celsius. Right now in Paris, it's cloudy with a temperature of around 14 degrees Celsius. I can also do find me the latest results of the World Cup qualifiers. So yeah, searching the web. Which World Cup qualifiers do you mean? Here are 4 recent highlights from the men's 226 World Cup. And here we have the sources. France was held to a 2-2 draw by Iceland in UEFA Group D. In South America, recent match day 70s include. So here we have the sources, because the sources are sources of truth. We know that this might be correct, because if we let LLM reason on its own, oh boy, it would hallucinate a lot. So we have also the sources of truth. So let's do a real world example here. I'm gonna move this here. Now I don't need anything. Let me clear my terminal. Let me reduce the size of it a bit. I'm gonna use the same environment that I wrote everything in. I just can't be arsed creating something new. Basically, what I want to do right now, I want to create a simple AI agent that will use OpenAI as its reasoning LLM. It will use Tavili, which is a web search tool, and it will use a langchain to wire everything together: tools, agent logic, and execution. And it can answer live queries like, find me the current temperature in Paris, what are the latest results, find me good AI jobs, what's new with Google, what's new with SpaceX, etc., etc. So we need 3 core packages, and I think I already have langchain. Do I? Oh, this environment is externally managed. To install Python, blah 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 blah. So I don't know why I'm using this terminal, but it's integrated here. Okay, I moved inside my terminal. I moved my working environment. I moved myself to be in this working environment. So langchain. Have I already done this? UV add langchain. I already have this. UV add langchain OpenAI. I already have this. UV add langchain tchdy. Okay, I don't have langchain tchdy. Let me just all add UV add tchdy pipe. I forgot I was using UV, so I was trying to hit it directly with pip. So again, each library, what it does, we have langchain, which is, where's my project here? I have langchain. Langchain is the core framework, the core orchestration framework. Chains, agents, tools, memory, everything. OpenAI, this one is specific to OpenAI models. It's connecting to them, to LLMs, embeddings, and tools. tchdy, I'm gonna talk about this. This is a search tool integration, which is a web search API. This is what's the name? Yeah, this is the package, and tchdy itself is an underlying web search service. Now, what is tchdy? Let me open it. That's tchdy. It's a web search API for LLMs. It's like a Google for agents. What will it do? It will give search results like titles and URLs and snippets that are easy for LLMs to interpret. And langchain will wrap it into a tool called tchdy search results, which lets our agents call the internet like this, which is basically the main thing. We can say tchdy search, and then I say input latest World Cup. Results. And the tchdy will return a list search that our LLMs can summarize. So what we need to do is, I need to sign up. Let me just do this quickly. So I just signed up via Google. And pay as you go. No, I don't want to pay as you go. To continue, you must add a payment method. Do I have a free tier? What the hell, man? Is everything now? What the hell? Is everything? Alright, no it isn't. A good thing about tchdy is that you have this researcher tier where we have 1,000 API credits, free monthly, no credit card required, and there's also some email support, which is really cool. What tchdy does is it provides us with a tchdy API key, which now I'm gonna set in my environment on my other screen, so you don't see anything. Let me move my screen to my window to my primary screen again. All right, I set up my tchdy API key. The tchdy API key should be written like this. So tchdy API key So let's build a minimal working example. From langchain OpenAI, import chat OpenAI. From the fuck lang all right, import tchdy search results. It's only tchdy search. Is it some tool that queries a tchdy search API and gets back JSON? So assume it was tchdy search results before, now it's tchdy search. Let's see. If we get any issues here, we are going to fix them as we are going through this. So create React agent executor from langchain import hub. What hub is basically a public registry of prompt templates, agents, and chains. It's like an npm for AI workflows, and we can load like agents that are ready made or prompts from the hub instead of building them from scratch. For example, can I open it? Langchain hub. And here are these templates. Answer the following question as best you can. You have access to the following tools, and we have here a list of tools, and we can use the following format. Oh, I should also sign up to Langsmith. Let's see if I will need it. Let's see if I will need it. I will most probably need it, but let's make sure.